Good afternoon, everyone, and welcome to the Q&A session 17 from the playlist of IIT-JEE Advanced Physics, Part 2. The topic is the concept of electrical field and the electric potential. And this is the question which I have taken for this session, which was asked in the IIT-JEE examination in the year 1999. So the question here is, an elliptical cavity is carved in a conductor as shown. So this is a conductor and this is an elliptical cavity. Elliptical cavity means cavity will be something like this, like this. So there is a charge Q here placed. There is a charge Q which is placed at the center of this cavity. And there are 2 points on the surface of the cavity as shown in this figure. This is one point A and this is the another point B. So, in this question there are 4 options given here. That is, first option is the electrical field at A is equal to electrical field at B. The second option is that the potential at A is equal to the potential at B. That is, electric potential at A is equal to electric potential at B. The third option is that the charge density at A is equal to charge density at B. And the fourth option is that is the total electric flux which is passing through this cavity is equal to Q upon epsilon naught, where Q is the charge enclosed by this cavity. That is the charge which is placed at the center of the cavity. So we have to find the correct option out of these 4. So there is a possibility that more than one options might also be correct. So the first option here is that the electrical field at A is equal to electrical field at B. Now we know that the electrical field is directly proportional to Q upon R square, where Q is the magnitude of the charge and R is the distance between the point at which we have to find the electrical field intensity and the point at which this charge Q is placed. So since E is directly proportional to Q upon R square, so in this case, since OA is less than OB, therefore the electrical field intensity at A will be more than the electrical field intensity at B. So this option A is wrong. The second point is the electric potential at A is equal to the electric potential at B. Now we know that in the case of a conductor, the electrical potential at all the points on the surface of the conductor are equal. Therefore the electric potential at A will be equal to the electric potential at B. So this is this option B is correct. Now let us come to the third option. The charge density at A is equal to charge density at B. Now the charge density depends on the volume or the surface area or the length over which the charge is distributed. So here, since OA is less than OB, therefore this charge density at A will not be equal to the charge density at B. So this option is also wrong. The last option is that the total electric flux through the cavity is equal to Q upon epsilon naught, where Q is the charge enclosed by this cavity and divided by epsilon naught, where epsilon naught is the permittivity of the free space. So as per the Gauss law, the flux is equal to Q upon epsilon naught, and the flux is also equal to EA cos theta, where E is the intensity of the electric field, A is the area of cross section of the closed surface and through which these electrical field lines are passing, and theta is the angle between the direction of the electric field and the normal to the surface. Now we know that in the case of a conductor, the electrical field lines are not able to penetrate through the conductor. So the electrical field lines, due to this charge which is placed at the center of the cavity, will not be able to penetrate in the downward direction and in these 2 directions as shown by these 2 arrows. The electrical field lines will be able to pass in the upward direction as shown by this arrow, because this is an open area. So some amount of flux will pass in the upward direction. However, the total electric flux Now through this cavity, this will not be equal to 0, will not be equal to Q upon epsilon naught, because the electric field lines, because of this charge Q which is placed at the center of the cavity, will not be able to pass through the conductor in the direction as shown by these arrows. That is, it will not be able to penetrate through this conductor in the downward direction and through the sides of the conductor. So some amount of electric flux will be passing through this open area in the direction as shown by these arrows, because the some of the electrical field lines will be passing in this upward direction through this open area. So the electrical field which will be passing through this cavity, this will not be equal to Q upon epsilon naught. So this option is also wrong. So the only option which is correct is the B, that is the potential at A is equal to the potential at B. So thank you very much for joining this session. In the next session, I will be coming up with a different type of a question from the chapter of electric charges and fields. So till then, have a nice day. Bye.